Hello, I am Allie Buchanan, and today I'm going to talk to you about my research on the impact of tropical cyclones on the spatial distribution of tornadoes in Alabama, specifically focusing on Baldwin and Mobile counties. The image on the right shows the total number of tornadoes per county from 1950 to 2022. There is an apparent maximum in Baldwin and Mobile counties, which are in southwest Alabama. These counties are on the coast of the Gulf of Mexico, with Mobile Bay in between them. There's a common myth that tornadoes are less likely to occur near large bodies of water. This image shows otherwise, and my research will try to determine why there are so many tornadoes in Baldwin and Mobile counties. This could be important to the citizens that live there or for emergency management personnel. Synoptically, southwest Alabama is impacted by both frontal systems in the fall and spring, while summer is generally characterized by high pressure with tropical cyclones and daily sea breeze circulations. This image shows the tropical cyclone tracks in the Gulf of Mexico from 1950 to 2022. It shows that Baldwin and Mobile counties are frequented by tropical cyclones, which mostly occur during hurricane season from June 1st to November 30th every year. Baldwin and Mobile counties are highlighted, as you can see, in the southwest part of the state, and the tracks are color-coded by intensity, with blue being weaker hurricanes and red being the stronger hurricanes. There's plenty of literature on both tornado climatology and tropical cyclone climatology. Focusing on the southeastern U.S., research shows that areas near the coast lack a distinct tornado season, as they're impacted by both mid-latitude cyclones in the spring and fall and tropical cyclones in the summer. The southeast sees a second peak in tornado activity during the cool season. One paper stated that the Gulf Coast and southeast U.S. sees 68% of all cool season tornadoes, which occur in the warm sector ahead of synoptic scale systems. That research helps explain the tornado climatology that we will see in subsequent slides in Baldwin and Mobile counties. So changing gears a little, there's also several papers that state that there may be population biases associated with tornado reporting, with a higher number of reports near heavily populated areas. This is something that will briefly be touched on in my research to see if it has any impact on the area of interest. Delving into the literature on tropical cyclone tornadoes, research shows that many landfalling tropical cyclones produce tornadoes, especially in strongly sheared environments. These are most common within 100 kilometers of the coast, as strong near-surface winds move inland and then slow due to friction. This especially occurs at locations that are far enough inland for friction to slow the low-level winds, but close enough to the ocean for upper-level winds to maintain their speed. Tornadoes are also most common in the right front quadrant of the tropical cyclone relative to their movement, and they occur most often in approaching outer rain bands. All of the information seen in this literature review is seen throughout my research as well. The question that this research will explore is what causes the apparent tornado maximum in Baldwin and Mobile counties. My hypothesis is that the apparent maximum is associated with the number of tropical cyclones that impact the area, causing Baldwin and Mobile counties to see more tornadoes than the rest of the state during hurricane season. I expect to find a statistically significant difference between the number of hurricane season tornadoes for Baldwin and Mobile counties compared to the rest of Alabama. Briefly taking a look at my methodology, I first looked at historical data from 1950 to 2022 to paint a clear picture of tornadoes and the synoptic setup surrounding them. Data included tornado touchdown points from the Storm Prediction Center, hurricane track information from the National Hurricane Center, as well as archived satellite and radar imagery from the National Center for Environmental Information. I used this data to analyze the spatial distribution patterns as well as compare seasonality between Baldwin and Mobile counties compared with the rest of the state. There are a few possible limitations to this research, including there could be multiple entries for a tornado if it touched down more than once. The number of reports also increased drastically in the mid-1900s, which is something that I definitely saw when collecting the data. There's also a potential for a bias of reports near heavily populated areas. For tropical cyclone tornadoes, it can also be difficult to determine if damage was from a tornado or from a tropical cyclone, which can impact the number of tornadoes that are reported, and it can affect intensity ratings. There are also known GIS plotting errors which could occur when using ArcMap, which is something that I used heavily in this research. Taking a look at some of the historical data, first I plotted all of the tornado touchdown points from 1950 to 2022 across the state in order to get an account for each county. The image on the left shows the result of that with the total number of tornadoes per county, with the counties in red having the most and the ones in blue having the least tornadoes. You can see the maximum that is in Baldwin and Mobile counties in the southwestern part of the state, as well as Jefferson County in the north central part of the state. The images in the middle and on the right show each tornado touchdown point as an XY coordinate, colored by magnitude. The legends for the color scale are beneath each of those images. Most tornadoes in the state, but especially in Baldwin and Mobile counties, are weak, being less than EF3. Second, I plotted all of the tropical cyclone tracks from 1950 to 2022 for the Gulf of Mexico. Then I applied a 100-kilometer buffer around Baldwin and Mobile counties and considered any hurricane tracks that passed within that buffer to have impacted the counties of interest. And I based this on the literature that we saw on a previous slide. These tracks were then cross-referenced with the tornado touchdown points on the previous slide to see how they overlapped. This slide shows a few examples of some of the types of imagery that was used for this research. These images were used to determine the weather events surrounding each tornado in Baldwin and Mobile counties specifically. The image on the top left is an example of a hurricane. It shows the spiral rain bands of Hurricane Katrina that did produce tornadoes across the area. The bottom left is the spring season event example with discrete cells ahead of a squall line with embedded tornadoes. These occur commonly in the area. The top right image is an old weather map that shows Tropical Storm Hermine. The bottom right is a satellite image of Hurricane Camille in 1969. Images were found for each tornado that occurred in Baldwin and Mobile counties in order to determine what type of weather pattern the tornadoes were associated with. Interestingly, only about 15% of the tornadoes resulted from tropical cyclones. And I'll talk more about what that means in future slides. The use of radar imagery likely has an impact on the numbers that I found. Radar wasn't introduced until the 1990s, and it has since seen significant advances, which make it easier to identify tornadoes related to tropical cyclones. Prior to this, they were harder to distinguish from tropical cyclone damage itself, and thus fewer tornadoes were likely reported. Getting into the results, first we will look at the spatial distribution patterns that were revealed. An optimized hotspot analysis was done for the entire state, and that is the image on the left. It revealed 3 distinct hotspots, one of which was over Baldwin and Mobile counties, and there was another one near Jefferson County in the northern part of the state. You can see in the hotspot analysis that the hotspot is just inland and along the bay in the southern part of the counties. It's just inland and not right on the coast, which is important and ties back to the literature that we saw where tornadoes are more likely a little bit further inland, but still close enough to the shore for shear to occur. The image on the right shows a point density analysis, which was performed for the counties of interest. This revealed a very similar pattern to the hotspot analysis, with a high density of points just inland and along the bay. The higher density of touchdown points is represented by the darker blue circles in this image. Then I overlaid the major cities on the density analysis and did see that point densities are high near major cities, but this could be coincidental because a lot of the major cities are just inland and along the coast. So this is something that will need to be further investigated. This slide depicts the primary findings of the research, focusing on tornado seasonality of the counties of interest compared to the rest of the state. The image on the left shows the two zones that were used for analysis and testing. Zone 1 consists of Baldwin and Mobile counties, while Zone 2 consists of the rest of the state. Tornado touchdown points were counted for each zone and then analyzed. The circular graphs in the middle show the percentage of tornado touchdowns that fall within each season. The dark blue color represents hurricane season, which is June through November, while the lighter blue color represents months outside of hurricane season. We can see that over half of the tornadoes in Zone 1, close to 55%, occurred during hurricane season. Zone 2, however, is the exact opposite, with the majority of tornadoes occurring outside of hurricane season, with only 29% during hurricane season. This pattern is further illustrated by the graphs on the right, which break down tornado occurrences by month. Zone 2 shows a very distinct peak of tornadoes in the spring, especially in April. There's a second smaller peak in the fall towards November, but very few tornadoes occurred throughout the summer. Zone 1, however, shows the lack of a single tornado season, with tornadoes occurring throughout the entire year. Hurricane season is months 6 through 11, June through November, and we can clearly see here that Zone 1 experiences more tornadoes during hurricane season than Zone 2 does. To determine if there was any statistical significance to this, I decided to test the two areas for statistical difference. First, tornadoes were counted for each year in each zone. These totals were then divided by the areas of the two zones to account for the fact that tornadoes are still relatively rare events. This would normalize the values across the regions and eliminate potential bias. The tables on the left and right show the normalized values that were obtained. The image on the left shows the hurricane season values, and the image on the right shows the overall values throughout the entire year, not just hurricane season. These images are really only here to show what data the test was performed on. The test was done twice, once comparing hurricane season tornadoes in Zone 1 and 2, and the second comparing all tornadoes in Zone 1 and 2. For hurricane season tornadoes, the p-value returned a value that enabled me to reject the null that there was no difference between the zones during hurricane season. However, for all tornadoes, the p-value returned did not enable me to reject that null. So, what does this mean? This statistically shows that there's not much difference for the number of tornado touchdowns throughout the entire year between Zone 1 and 2. However, when you isolate the number of tornadoes during hurricane season specifically, there is a statistically significant difference between the zones. We saw that in the charts on the previous slide, with Zone 1 having more tornadoes during hurricane season than the rest of the state. This research shows that the main difference between the number of tornadoes in Baldwin and Mobile counties compared to the rest of the state is tied to hurricane season. This is readily apparent when looking at the monthly totals on the left, which show that more tornadoes occur from June through November in Baldwin and Mobile counties than the rest of the state. This effectively causes these counties to have a less distinct tornado season and boosts the overall numbers. Although only 15% of the tornadoes were directly related to tropical cyclones, without that 15%, the number of tornadoes in these counties would be lower and more closely resemble the rest of the state, and there would be less of a maximum in the area. During hurricane season, the region is characterized by higher instability, a greater land-sea temperature difference, more latent heat release over the water, and other factors that likely enhance tornadogenesis with even non-tropical systems during that time of year. The literature stated that tropical cyclone tornadoes are especially likely in areas that are far enough inland to slow the low-level winds, but close enough to the water for upper-level winds to maintain their speed, thus increasing shear and making tornadoes more likely to form. It is probable that this has an influence on all storms that move onshore during hurricane season, whether they are related to tropical systems or mid-latitude cyclones, and that is something that will need to be further investigated. Though this research focuses on a specific area, it adds to the existing literature by investigating the seasonality of tornadoes in coastal counties. It also generates ideas for further research, which could investigate the frictional influences as well as the effect of Mobile Bay on the storms. It also provides a better understanding of the environment for the citizens that live there, as well as for public officials and emergency managers. These are a few of my references. Thank you for listening, and I look forward to feedback and questions.